value should be fully transmitted to concrete at the end of your member itself. Now, say for example, if this is your member, you are laying your cable. Theoretically, you are going to assume that now your P value would be transmitted fully to our concrete at the ends itself. But in actual scenario, this won't happen. Now, similarly, likewise, whenever you come to your post-tension members. Now, post-tension members, we see that you're going to have some locking devices, what we call as anchorage devices, or bearing plates. Now, this is going to, exert your pre-stressing force by and anchorage, say something like this. You have some locking devices which is going to prevent moving of your cable inwards. Now, these locking devices are going to exert some pressure on your beams. So theoretically, whenever you come to pre-tension members, now this won't happen. Now, this theoretical value of P doesn't happen exactly at the face of your concrete member. Whenever you come to what exactly happens, can you see this?
Yes, sir.
Yeah. Now say this is my original diameter. This is my original diameter. Are you looking at my screen?
Yes, sir.
So this yellow color is my cable with original diameter D. So which is again in a state of high tension. Now by this time you'll be knowing how much force you're going to apply. So this cable is in a state of very high tension. So whenever you start releasing this cable, now you see your Poisson's effect. How Poisson's effect now this end of your cable or this end of your wire is very free to expand. Is it?
Yes, sir.
In fact, when this is going to expand, like you see Poisson's effect, lateral the delta D by D by delta L by L. Is it? Now at this end, now your cable would be swelling off. So as and when this starts swelling out, now your P value actually would be zero. Your P value won't be P at this end. So for P to happen, now this takes some length. Now gradually, as and when this starts swelling out, now you're going to see some wedge action. Now this wedge action, what is shown in on this figure, where exactly my mouse is getting pointed out. Can you see my mouse pointer?
Yes, sir.
Yeah. Now this at the end, yeah, you're going to see some wedge action. Now, as and when this wedge action is formed, now this is going to exert some pressure on the surrounding concretes, and this pressure would be your bursting tension. How your cable is trying to reach its original position, and you have some concrete interface which is going to oppose this. Got it?
Okay.
Again, at this end, your cable is very free to expand because we have released this cable. So during this mechanism, now as and when wedge is formed, now this wedge starts exerting pressure onto your concrete, and this pressure would be something like a tension. So this is one part. Got it? So
Okay, sir.
actually your P value would be zero at this point because of your wedge action. Now slowly P which is zero here at this point would be slowly reaching to its maximum value, which is of P. So the length required for achieving this P value from 0 to P is called transmission length. So this would be critical in your pre-tension members.
Okay, sir. Yes,
So
sir.
the length of the transmission length will be represented by LT. So you require some length for slowly or gradually introducing of our pre-stressing forces. Pre-stressing forces 0 at the face of my concrete member to its maximum value. Now you can see like figure 9.1 distribution of your stresses. Stresses in concrete. Now zero at the face of your concrete member. Now slowly this is going to increase and take a length. It will have a length of LT. So by this in this length, your P value, which is for a zero at face of your column, would be reaching maximum value of P. So this
Okay.
entire mechanism, what I'm explaining, is shown in this diagram. So this wedge action formation and then slowly introduction of your forces from zero to maximum value of P is called Hoyer effect. Since Hoyer was the engineer who started talking about this pre-tension member. So this entire phenomenon is called as Hoyer's effect. And then whenever you look at this next figure, now this starts this cable is trying to come inside and you have a concrete which is opposing this. So during this process, now you see some transverse tension or bursting tension happening in our member. And this will be maximum at this location. Slowly this is going to reduce and this is going to reach a value of zero. Now exactly this happens. This figure.
Okay, sir.
Now this is my tension. What is happening at this phase due to wedge action? Now slowly this is going to get nullified at a length of my transmission length LT. Now my tension would be 0. So this zone is called end zone in pretension member. Rather than like in this zone, like this tensile stresses due to your OS effects and wedge effects are to be nullified. Got it? So in
Okay,
this process, we are going to see what would be equations for getting a transmission length LT and what would be equations for a bursting force FBT. Got it?
okay,
Yeah, now let us come to the stem, like the things what we have discussed till now. So in a pre-tension system, when a wire is released from its temporary anchorage on the pre-stressing bed, like this is something like releasing our cable, cutting our cable. The end of the wire swells as a result of recovery of lateral contraction and develops a wedge effect. Is it? As I
yes,
start
sir.
releasing this, now this end is very free to expand.
Expand.
Whenever you go to interior, now you have some concrete mass which is going to hold this. But at this end, now this your cable is very free to expand. Got it?
Yes, sir.
Some wedge is going to get developed. Now this is to enable pre-stressing force to become zero at the end of the wire. This is generally referred as Hoyer's effect. The swelling of the wires is only a few thousandths of a millimeter, which is very negligible. Something like a gauge strains what we have seen in our previous class. But its effects
Yes.
will be abnormal. But it nevertheless produces a considerable radial pressures on the concrete, giving rise to large frictional forces. So as and when this starts moving, the bulging out in lateral direction, this starts producing some tensions or bursting tensions on the concrete surrounding concrete. Okay, the transmission of pre-stressing force from steel to concrete is generally through a bond compressing of. Now we have seen, is it the main reason for development? Main reason for transferring of your pre-stress from cable to a concrete is by bond. Is it? This is agreed long back.
Yes.
How now this is stretched in elastic limit. Now as and when you start releasing this cable, now this starts moving inside because of elasticity. Now you have a concrete mass which is going to hold this. So one is trying to oppose your motion, and second one, your cable is trying to move inside of your concrete. So this, frictional force or when resistance between these two materials is going to induce or is going to transfer pre-stressing forces from cable to our bond. From cable to our concrete. Got it? So this bond will be compressing of addition between concrete and steel. Now this occurs due to chemical reaction at the interface. So how this bond is going to happen? The first thing would be addition. Now addition, like if you have any chemicals in your cement concrete, now this will be acting something like a gum. So
Okay, sir.
very negligible and which would be moving off very easily. The second one is called shearing resistance or mechanical bond. So this is main reason for achieving when bond between our cable and concrete. Majority of our bond is by mechanical bond only.
Okay, sir.
This mechanical bond is going to happen because of twisting happening or because of our twisted strands or twisted wires. Got it?
Okay,
So we
sir.
all know no, deformed bars are going to have a lot of bond stresses. Why? Because twisting happening in your member is going to hold your concrete. Got it?
Okay, sir.
Yeah. The third one is by friction. Again, this is also would be very less compared to our mechanical bond. So these are the three different ways of achieving bond between steel and concrete. So friction, mechanical bond, and adhesion. So the third is the friction in the presence of transverse compression. Well, what is this transverse compression? Now you have concrete above your cable. You following?
Yes,
If
sir.
you start laying your cable somewhere over here, now you have concrete above your cable. Now concrete weight is going to compress your cable. So this compression from top is going to induce some friction. Got it?
Okay, sir.
So out of all these three, our mechanical bond is the main reason because of twisting happening on our cables, strands, or wires. There would be bond between our steel and concrete. Got it?
Okay, sir.
Yeah. Now at intermediate points along the length of the beam, the bond stresses is resisted by adhesion, while in the transfer zone of the tendons invariably slip and stick into the concrete, destroying most of the adhesion. Got it? So at intermediate points, now you may see some effect of adhesion, but at this point, now you see a lot of mechanism happening in the end zone. You have ejection happening, like you will be having insufficient covers, concrete would be filling up, spanning happens, and all these things happen. So in this case, definitely adhesion won't be like important in this end zone. Consequently, the bond stresses are due to friction and shearing resistance. The distribution of bond stresses, stress in steel and concrete in the transmission zone as shown in figure. So the length needed for achieving this is termed as transmission length. Got it? So the length required for achieving this, what is this? A p value 0 at this end to a value of p, maximum of p. Now this length required is called transmission length.
Okay, sir.
Generally represented by LT. Now this is there for pre-tension members. So this transmission length won't be there for post-tension members. Why? Because at the face of your column directly you're going to, at the face of your concrete member directly you're going to induce pre-stressing forces. So there the mechanism would be different. Okay. The transmission length depends upon mainly diameter of the diameter and surface characteristics of the wire. Like if you are if you have more diameter, like you have more bond, where your length would be very less. Likewise, whenever you have a plain wires compared to twisted wires, definitely plain wires would be very easily moving inside. Got it? All these things are going to influence your transmission length. Like a quotient of friction between my steel and cable would be a factor for determining this transmission length. Now this figure is in order with wedge action, and then the length required for p value from 0 to p for achieving from 0 to p value is called transmission length, generally represented by LT. Got it?
Okay.
Yeah. Now these are the factors on which your transmission length is going to depend. Now all these are self-explanatory. You can look into this now, which depends upon type of tendon, shape or size of your tendon, stress in tendon, surface deformations of the tendon like plain, indented, twisted or deformed, strength of the concrete at transfer, strength of the concrete at transfer. Now why, if you go for higher grades of concrete, now definitely you're going to have more amount of bond stress. Like quality of your CHSL will be very high.
Yes, sir.
And then it offers lot of bond resistance to your cable. So pace of cutting tendons. Now pace of cutting tendons. Now this is like how you are going to release our cables. Generally, whenever you come to releasing of your cables in casting yard, would be something like directly cutting using our mechanical saws or by gas cutting.
Okay.
So you want to use gas cutters for cutting this. Now I don't know how many of you seen in railway sleepers. At the end of railway sleepers, you're going to see some dots and black thing, like black marks. Now these are done by gas cutting.
Okay, sir.
Like try to see like railway sleepers, modern day railway sleepers, concrete sleepers. You want to see small dots. No, those dots are pre-tension cables, and you can see black, carbon surrounding your cable, surrounding your wires. So those are done by gas cutting. Like if you start releasing your cable all of a sudden, now definitely this cable starts moving very quickly inside of your concrete, where you require more transmission length. Because if you start slowly, you're going to give time to our cable to adjust to the surroundings. Got it? So
Yes,
slow
sir.
cutting will be reducing our transmission length. Like again, presence of confining reinforcement. If you do confine your concrete, now definitely your confining of your concrete is going to increase strength in our concrete. So automatically this starts increasing bond stresses. Got it?
Okay.
Like effect of your creep, compaction of your concrete, and amount of concrete cover. All these are the factors which are going to define, which are going to influence our transmission length. Yeah.